In this video, we're going to review how to do some counting of atoms. So counting atoms, it's one of the first skills you actually need when you're balancing equations. So if you can't count atoms, balancing equations will be very tough. But once you master counting atoms, then balancing equations will be a lot easier for you. So let's start off with a simple formula like H2O. This small number over here is called a subscript. And what that does is it tells you how many of that element there is in that substance that you're dealing with. So right now in water, I know there's two H's, two hydrogens. And since there's no number next to the oxygen there, that's an implied 1 and 1 O. And that's a total of 3 atoms in H2O. So to count elements in compounds or molecules or different substances, you simply look at the small numbers next to it. So over here, if we have O2, the little 2 here means that there's 2 O's. And that's it. Let's do AlF3. There's 3 F's, and then there's 1 Al. That's a total of 4 atoms. Since it's ionic, we'd say ions, but we'll stick with atoms just to keep it simple for now. Sometimes the counting can become a bit more complex if you add a coefficient. So counting with coefficient. A coefficient doesn't change what the chemical is, it just changes how many you have. So for example, when I write 2H2O, what this means is that I have 2 water molecules. So rather than write H2O out twice, like this, I just write that to keep it simple. A coefficient multiplies all the subscripts in the substance you're dealing with by whatever that coefficient is. So if I want to find how many H's there are, well, there's 2 times 2. So 2 times 2 is 4 H's. If I want to find how many O's there are, well, then there's 2 times 1, 2 O's. And it makes sense, right? If I were to draw this out, there's 2 here, that's 4 H's. And then there's 1 here and 1 here, 1 and 1, that's 2 O's. So a coefficient will multiply everything by whatever that coefficient is. So let's say, for example, we have 3AlF3. So for aluminums, I'll do 3 times, don't forget there's a 1 there. So 3 times 1 gives me 3 aluminums. And then 3 times 3 gives me 9 fluorines. 9 fluorines. And then that would be a total of 12 atoms, which makes sense because we have 3 times more than what we had up here, right? So 3 times 4 is 12. And then for the water, we have 2 times more than what we had up here. So we have 6 atoms compared to 3. So 2 times 3 is 6. And so that's how you count with coefficients. And now we'll see one more layer here, and this is called counting with brackets. Sometimes your compounds that you have will have brackets in them. So AlNO33. And what happens when you have brackets is that anything on the inside of the bracket is multiplied by the subscript on the outside. So in this case, if I'm counting, let's say nitrogen, I have 3 times 1. It's 3 nitrogens. Oxygens, 3 times 3. That's 9 oxygens. Aluminum is not in the bracket, so it's 1 like that. So 1 aluminum. Then you can add them up for your total, 13 atoms total. Let's try this one here. So we'll do Al2CO3, 3. So here I have 3 times 3. That's 9 oxygens. 3 times 1. That's 3 carbons. Do not multiply the 2 for the aluminum by 3 because it's not in the bracket. So it's simply 2 aluminums. So this 9 plus 3 is 12, plus 2 is 14 atoms total. So when you have a bracket, just make sure the subscript multiplies everything on the inside of the bracket by whatever that number is. but leave everything else alone. We'll do one more example where we now have a bracket and a coefficient together. It's really not different. We're just combining the two rules together, essentially. And if we do it step by step and slowly, you'll be able to do it no problem. And then you'll just improve and get faster as you do more and more practice. So let's take the ALNO3 there, but put a 2 in front of it, a coefficient. So if you want to find the number of atoms total, just take it step by step. We'll start with oxygen. For oxygen, first we'll do 3 times 3. But then don't forget you have times 2 because of the coefficient in the front. Times 2. So that's now 18, right? 2 times more than what we'd have before. 18 oxygens. For nitrogen, 3 times 1. And then don't forget, though, times 2 as well. So that's 6 nitrogens. And then for aluminum, we don't multiply by the 3 because it's not in the brackets, but we do multiply by the 2. 2 times 1. Because don't forget the coefficient multiplies everything, right? Every single thing, regardless of whether it's in brackets or not. And so our total number of atoms here, 18 plus 6, 24 plus 2, 26 atoms. Whereas here we had 13 atoms, which makes sense. We have 2 times more, right? 2 times 13 is 26. We'll do one more together. We'll do this one here, 3Al2CO3, 3. And we'll go ahead and figure out oxygen first. So for oxygen, 3 times 3 times 3 again, because there's a 3 coefficient. So 3 times 3 times 3, 27 oxygens. For carbon, 3 times 1, and then times 3 again, because of the coefficient. So that's 9 carbons. And then for aluminum, it's not in the bracket, so we're not going to multiply it by the 3 here, but we're still going to multiply it by the big 3 in the front, because that multiplies everything, right? So 3 times 2 is 6 aluminums, and that gives us our total of 27 plus 9, 36, 42 atoms. Here we had 14 atoms. And that makes sense because we have 3 times more, right? This is 3 times more than the 14 atoms we had before. So that's counting atoms in nice, simple forms. We're regular forms here. We have just no coefficient in the front, or when our coefficient is actually 1, we don't write it down. You just look at the subscripts, and it's pretty straightforward. Just remember that if there's no subscript, it's a 1. We saw what happens when you have coefficients. So the coefficient multiplies everything, and with brackets, you simply multiply what's in the bracket by the subscript on the outside. Remember, subscripts are the small numbers, and then the coefficients are the big numbers in the front.